Greetings. Today our topic is about comparison of performance of high volume fly ash self-compacting concrete with normal concrete. Our external guide is Mr. L.S. Kannan sir from L&T. Our internal guide is Dr. D. Shivakumar sir, professor at Vale Tech High Tech Engineering College. The project is presented by B. Kirtana S. Lavanya Pavitra doing our final year civil engineering at Vale Tech High Tech Engineering College. The main aim of this project is to compare the performance of high volume fly ash self-compacting concrete with normal concrete. Introduction. More than 88 million tons of fly ash is generated in India each year. The percentage utilization is around 10 to 15% only. To increase its percentage utilization, an extensive investigation was carried out to use it in concrete. This article presents the comparative analysis of an experimental investigation dealing with concrete incorporating high volume of fly ash and the normal concrete. Portland cement was replaced with three percentages, that is 40%, 50 and 60% of fly ash. Tests were performed for fresh concrete properties and results are scheduled to be determined up to 56 days. These are the list of literature review we have preferred to carry out this project. This is the work chart which shows the step-by-step procedure we have carried out in doing this project. First, we referred to many literatures, then we collected the materials required for this project, and then we tested the materials to know their properties, and then we designed a mix for which the concrete shows higher strength. Then we carried out casting. After casting, we carried out 3 days testing and then 7 days testing, followed by 28 days testing, and then finally 56 days testing. Then we analyzed the results and then we concluded with the best performing concrete. The materials which were required for doing this project is ordinary Portland cement of 53 grade and then fly ash, admixtures, coarse aggregate, fine aggregate and water finally. The following methodology has been adopted in our project work. The trials were conducted and specimens were tested for required properties for the different combination. The first combination was fully ordinary Portland cement, that is 100% OPC, and then 40% fly ash and 60% OPC, then 50% fly ash and 50% OPC, finally 60% fly ash and 40% OPC. Material testing. We started the testing with fine aggregates. We used crusher sand for fine aggregate. We first started with sieve analysis with sieves ranging from 4.75 mm to 75 micron and then pan. The tabular column indicates the result of the sieve analysis. The tabular column consists of column of sieve sizes, weight retained in grams in each sieve, percentage weight retained in each sieve, percentage weight cumulative, percentage of passing in grams in each sieve, then IS limits for which the zone of the sand is to be declared. From the sieve analysis result, the sand was confirmed to be zone 2 and then we conduct a water absorption test. The result showed the average water absorption percentage was about 2.96% and the finest modulus is 3.118, which was concluded from all the sieve analysis testing, that is from fine aggregate and coarse aggregate. This picture was taken when we were doing water absorption test for fine aggregate. These are the fine aggregates and coarse aggregates which we have used in this project. After all the tests were completed for fine aggregates, then we carried out to coarse aggregate. There were two types of coarse aggregates which we were going to use in this project. The type 1 was first conducted with sieve analysis. In this, the sieve sizes range from 16 mm to 2.36 mm and then pan. This tabular column shows the result of the sieve analysis, which consists of weight retained in grams in each sieve and then percentage weight retained, percentage weight cumulative, percentage of passing. The highest limits were used to declare the type of coarse aggregate. Using IS limits, the coarse aggregate was termed to be 12.5 mm aggregate, with which we then conducted the specific gravity test with pycnometer. The average specific gravity was noticed to be 2.86, and then the water absorption test was carried out, which was found to be the average water absorption is 0.34% for 12.5 mm aggregate, which was type 1. There is two pictures shown. The first one indicates the type 1 aggregate and the second one indicates the type 2 aggregate, which we have used in this project. After carrying out all the tests for type 1 aggregate, then we carried out to type 2 aggregate sieve analysis. In this, the sieve sizes range from 40 mm to 4.75 mm and then pan. This tabular column shows the result of the sieve analysis with columns of sieve size, weight retained in gram in each sieve, and then weight percentage of weight retained, and then percentage weight cumulative, percentage of passing, the sieve analysis test and the IS codes, we confirmed the type 2 aggregate to be 20 mm aggregate. Then we carried out specific gravity test for 20 mm aggregate. The average specific gravity was found to be 2.8 and then water absorption test was carried out. Average water absorption percentage was found to be 0.27 percentage for the type 2 aggregate, that is 20 mm aggregate. The picture shows the type 2 aggregate. It is cement testing. We have tested the cement which we used for the project, and we found out the initial setting time to be 195 minutes, which should be about 30 minutes, and then final setting time is equal to 300 minutes we have obtained, which should be less than 600 minutes according to code. Picture shows the cement which we used for the project. We used Chettinadu ordinary Portland cement, that is of 53 grade. After all the material testing, the mix design was proposed. First, we started with all-in aggregate blending. Material composed of fine aggregates and coarse aggregates. Finally, fixed as per IS 383 1970. 100% should be obtained, for which coarse aggregate was taken to be 52% and fine aggregate was taken to be 48%. As we used type 1 and type 2 coarse aggregate, that is 12.5 mm coarse aggregate and 20 mm coarse aggregate, we blended it into two different percentages, that is 36% of 12.5 mm aggregate and 16% of 20 mm aggregate. As we said already, the four trials which we were going to conduct, we first proposed mixed design for 100% OPZ. Cement was obtained to be 0.1587 meter cube and free water to be 0.2000 meter cube. Admixture is 0.0040 meter cube. Totally, we should obtain 0.3627 meter cube. Weighted aggregate average for 20 mm aggregate, the specific gravity into weight in percentage, that is 2.80 into 16 percentage, that is equal to 0.448. For 12.5 mm, 2.84 into 36, that is 1.022. For coarse aggregate, 2.80 into 48 percentage, that is 1.344. Totally 2.814. 1 meter cube minus 0.3627 is equal to 0.6373 into 2.81 into 1000, that is 1791. Without the water absorption for this mixed design, we conducted this calculation. The tabular column shows the material required for casting 12 cubes, 9 cylinders and 9 beams. After completing 100% OPC, we carried out mixed design for 40% fly ash and 60% OPC. We took cement to be 0.0952 meter cube and then following fly ash, free water admixture respectively. Totally, we got 0.3944 meter cube. Weighted aggregate average was found to be 2.814. For 1 meter cube minus 0.3944 is equal to 0.6056 into 2.81 into 1000, that is 1702. Water absorption for this mixed design was calculated as given below. Tabular column shows the material and the amount of materials required for casting 12 cubes, 9 cylinders and 9 beams as I said before. Then we design a mix for 50% fly ash and 50% OPC. The water absorption for 50% fly ash and 50% OPC was found to be 26.6409. This tabular column shows the material and the amount of material required for casting 12 cubes, 9 cylinders and 9 beams respectively. As similar to all the mixed design, finally we ended up with mixed design for 60% fly ash and 40% OPC. The mixed design is given here. The water absorption is found to be 26.2773 respectively for this mixed design. This tabular column shows the material and the amount of material required for casting. Finally, after ending up with mixed design, the fresh concrete tests have to be carried out for knowing the properties. The three fresh concrete tests conducted was slump flow, V-funnel test and L-box test. First, the slump flow test is carried out. The slump flow is a test to access the flow ability and the flow rate of self-compacting concrete in the absence of obstructions. The slump flow classes are SF1, SF2 and SF3. Slump flow in mm was obtained to be 550 to 650, then it is said to be SF1 class, and then 660 to 750, then it's SF2 class, and 760 to 850, then it is SF3 class. This tabular column shows the result of the slump flow test. The mixed proportions are given in the first column and then the flow obtained for each mixed design is given in the second column. For 100% OPC, 630 mm was obtained. Then 40% fly ash, 640 mm. 50% fly ash, 660 mm. Finally, 60% fly ash, 610 mm was obtained. After slump flow test, it's V-funnel test which was carried out. The V-funnel test is used to access the viscosity and filling ability of self-compacting concrete. The classes are declared to be Vs1 divided by Vf1 and the ratio of Vs2 and Vf2. V-funnel time in seconds should be less than 8 for Vs1 bar Vf1 class and it should be 9 to 25 seconds for Vs2 and Vf2 class. This tabular column shows the result of V-funnel test. The first column indicates the mixed proportion and the second column indicates V0 in seconds. And then after 5 minutes, the third column indicates the result as V5 in seconds. For 100% OPC, V0 was obtained to be 12.48 seconds and V5 was obtained to be 12.56 seconds. Following, all the mixes were conducted for V-funnel test. At last, the test for fresh concrete is L-box test. The L-box test is used to access the passing ability of self-compacting concrete to flow through tight opening including spaces between reinforced bars and other obstructions without segregations or blocking. The passing ability PA is calculated from the following equation. PA is equal to the ratio of H2 bar H1, where H1 is the depth of concrete immediately behind the gate and H2 is the depth of concrete at the end of the box. The height of concrete passing in the L box were obtained, and then this picture shows the clear identification of the height of the concrete passing in the box. The tabular column shows the result of L box testing. The first tabulation indicates mixed proportions, and then second column and third column indicates H1 and H2. Last is passing ability of the concrete. After the fresh concrete test, the casting is to be undergone. So the concrete is poured in the molds. After casting and curing, hardened concrete tests have to be carried out to find out the compressive strength using cubes, and split tensile test should be carried out for cylinders, and flexural strength test is to be carried out for beams. These are the concrete blocks left for curing. Compressive strength. One of the fundamental properties used for quality control by testing cube is compressive strength. Out of many tests applied to the concrete, this is the utmost important, which gives an idea about all the characteristics of concrete. By this single test, one judges that whether concreting has been done properly or not. This is how the compressive strength tests have been carried out for cubes. Following every test we carried out, we have tabulated the results of each mixers for every 3, 7, 28 and 56 days with the testing date into a tabular column. The tabulation shows the load which we have given and which the cubes can bear, and the strength of each cube, and average we have found out for each 3 days and 7 days, 28 and 56 days testing. This is the test result of compressive strength for 50% fly ash cubes. This is the test result for compressive strength of 60% fly ash cubes, which was casted on 21/12/2015. Followed by compressive strength testing, it is split tensile test. The tensile strength of concrete is one of the basic and important property. Splitting tensile strength test on concrete cylinder is a method to determine the tensile strength of concrete. The concrete is very weak in tension due to its brittle nature and is not expected to resist the direct tension. This picture shows how failure occurs in cylinder when the load is applied, and the split tensile test is carried out by this way. As we have tabulated the result for cubes for finding out the compressive strength average, same we did it for cylinders to find out the split tensile test. This tabular column consists of casting date for each mixers and then testing dates and the age of these cylinders, that is 7, 28 and 56 days, then weight of each cylinders for which the test is carried out, and the load which it can bear. Finally, the strength and the average strength is found out. This tabular column shows the result for 40% fly ash cylinders, which was casted on 17/12/2014. This tabular column indicates the result of 50% fly ash cylinder mixes which was casted on 18/12/2015 and the test was carried out on 25/12/2015 for 7 days and 15/1/2016 for 28 days and 12/2/2016 for 56 days. The average strength was obtained to be 1.84 for 7 days and 2.13 for 28 days and 2.95 for 56 days. This tabular column shows the result for 60% fly ash cylinders which was casted on 21/12/2015. The testing dates were on 28/12/2015. Flexural strength test. Flexural strength is one measure of the tensile strength of concrete. It is a measure of an unreinforced concrete beam or slab to resist failure in bending. This is a picture showing the failure of the beams during flexural strength test. As we did for compressive strength test and split tensile test, we also tabulated the result we obtained from flexural strength test. In this tabulation, we have casting date, testing date, age, weight, load, strength and average. The, the tabular column indicates the casting of 100% OPC beams testing. The casting date was 16/12/2015 and the testing dates was on 23/12/2015 for 7 days and 13/1/2016 for 28 days and 10/2/2016 for 56 days. The average strength was obtained to be 1.72 for 7 days, 2.18 for 28 days and 2.83 for 56 days. This tabular column shows the result of flexural strength test for 40% fly ash beams which was casted on 17/12/2015. The average strength was obtained to be 1.91 for 7 days and 4.06 for 28 days and 4.10 for 56 days. This tabular column shows the result for 50% fly ash beams which was casted on 18/12/2015. The average strength obtained on 7 days was found to be 2.45 and 28 days was found to be 4.17. Finally, 56 days it is giving 4.25 strength as an average. This final tabular column indicates the result for 60% fly ash beams which was conducted for flexural strength test and casted on 21/12/2015. The testing date was on 28/12/2015 for 7 days. The strength was obtained to be 4.13 as an average strength. Then it is on 18/1/2016 when the second testing was conducted which was on 28 days of its age. 4.676 average was obtained. The testing date next was on 15/2/2016 which was 56 age days test. The average was obtained to be 4.77. Result and discussion. Comparison of performance of high volume fly ash self-compacting concrete with normal concrete is done successfully. This study gives the complete result for compressive strength for cubes, split tensile strength for cylinders and flexural strength for beams which was made with the material testing of 53 grade OPC cement, fine aggregate and coarse aggregate of 20 mm and 12.5 mm. All the tests were conducted as per IS codes. Mixed design was made with the use of test results. Results are discussed in the following graphs. This graph shows the result for all the mixes during all its age days, that is on 3, 7, 28 and 56 days for cube. This shows that 60% fly ash combination gives the highest strength which can be adopted. This graph shows the result of split tensile test which was carried for cylinder for 7, 28 and 56 days. This graph was driven from the result of flexural strength test. Finally, we conclude that 60% fly ash mix gives the highest strength in all cubes, cylinders and beams for every 7, 28 and 56 days compared to every mixes. So, finally 60% fly ash gives the best result and can be adopted for essential uses. Conclusion. Compressive strength for cube, split tensile test for cylinder and flexural strength for beam was conducted and readings were noted for 3, 7, 28 and 56 days for different ratios of fly ash. The graph shows the variation in the strength and the graph for 100% OPC increases gradually and falls down after its peak, but with the proportion of 40% and 50-60% fly ash will keep on increasing parallel beyond the peak of 100% OPC. From the graph and reading taken, it is clearly showing that proportion of fly ash with the cement will increase strength of the concrete even in low proportion. Thank you.